So we just talked about an AC circuit that has got a resistor in it. So now let's talk about an AC circuit with a capacitor. So here we have AC circuit containing only capacitors. So we have AC circuit containing only capacitors. And remember, I told you that the difference between an AC and DC circuit is mainly in the effects of capacitors and inductors, because then something different begins to happen to both the current and the voltage. So here we have, here is a simple diagram of the simple AC circuit with a capacitor. So here we have the diagram of the simple AC circuit with a capacitor instead of a resistor. So both experiments and theory show that in this kind of AC circuit, with only capacitors, the current leads the voltage and the voltage lags the current by 90 degrees or 1/4 cycle, quarter of a cycle, or pi/2 radian. Pi/2 radians. So as soon as you introduce a capacitor into a simple AC circuit, what happens is the current and the voltage go out of phase. That means the amplitudes do not occur at the same time anymore, and that the current leads the voltage while the voltage lags the current by pi/2 radians or 1/4 cycle or 90 degrees. So when we apply the Ohm's law, before we do that, this means if the instantaneous voltage is given as V0 sine omega t, then the instantaneous current would be I0 sine omega t plus pi/2 radian, because the current will always lead the voltage and the voltage will always lag behind the current. That is in an AC circuit containing a capacitor. You see? Okay. Now, when you apply Ohm's law to this, using Ohm's law, we know that V is equal to IXC. V is equal to IXC. Now this one brings to mind V equals IR, right? It brings to mind V is equal to IR. And that means this XC and IR are a sort of opposition to the flow of current. Of course, both R and XC are an opposition to the flow of current. With XC being the opposition to the flow of current, to current offered by a capacitor. It is known as capacitive reactance. So here we say both this XE and R are an opposition to the flow of current, with XE meaning capacitive reactance, that is the opposition to the flow of current offered by a capacitor in an AC circuit. Now, capacitive reactance is also given as 1 over 2 pi Fc. Yes, this is the formula here. And that means this equation here, this equation 1, and this one is 2. Equation 1 becomes V is equal to I all over 2 pi Fc, or V is equal to, or I is equal to V multiplied by 2 pi Fc, where all symbols carry their usual meaning. You see? So we can use this formula here to solve questions on a simple AC circuit containing only capacitors. So we're going to do this in the next, as the next step. So let's do a recap here. So here we said AC circuit containing only capacitors, and here is a diagram of such a simple AC circuit. You can see the symbol for capacitor here. In place of a resistor, which is what we've been dealing with, we have a capacitor here, which is represented by a symbol of 2 equal bars. Now here we said both experiment and theory shows that this kind of AC circuit with only capacitors, in this kind of AC circuit with only capacitors, the current leads the voltage. Now it is a shame that I don't know how to give it to you, how to prove to you from theory that current leads voltage. But I think it's a very good question to ask. How can we know current leads, at least through theory, that current leads the voltage in a simple AC circuit containing a capacitor? So, and the phase angle between the current and the voltage here is 90 degrees, 1 over 4 cycle, that's a quarter of a cycle, or pi over 2 radians. So if the instantaneous voltage is given by this formula here, times the instantaneous current will be given by this formula plus the phase angle with which it's leading the voltage. So you have to add that to it, because the current leads the voltage. So now when we apply Ohm's law to this, you see that V is equal to IXC, where XC here is an opposition to the flow of current offered by a capacitor called capacitive reactance. And mathematically it's given by X is equal to 1 over 2 pi FC, where F is the frequency of the AC source, the capital letter C here is the capacitance of the capacitor, and of course 2 pi is a constant term. So if there's any question, you let me know in the comments.